we need to do something which is called scaling. We need to adjust our bars and our positions of the bars to the available surface, so to the available canvas size and our data. And both matters, of course. We also need to respect the size of this box here, which the user, of course, is able to resize. We want to take this into account to make sure that our bars are having the appropriate height and width, and we always take the full available width and height so that our chart scales with the size the user assigns to it. But besides this canvas size, it also matters to us that we take our data into account. And that, for example, includes the number of data points. For the width per bar, we need to split the available width by the available data points, but also the values which we want to chart, so that we respect this in the height of our bars. And thankfully, all that scaling is made easy by the Three.js again. For that, here an update, maybe before we even start with the bars, we can create a new x constant. And that will soon be a function, a command we can call to give us the appropriate position along the x-axis and to give us the appropriate width. Now, not like this, however. We need to store some value in there, and we need to store some value which we get from d3. From d3, we can import scale band. And whilst we're here, we can also already import scale linear. Now, these are two scaling helpers exposed by d3, and scale band is basically a helper that helps us with ordinal scales, so where every item has the same size as our bars have on the x-axis, and where just the order matters. And scale linear, on the other hand, is there if we have continuous data, and we, for example, want to make sure that this bar is higher than this bar. So for the x-axis, we will need scale band. And we simply execute this command by adding parentheses after the command name. And on this, we can now call domain, another subcommand, so to say, if you want to call it like this. Domain allows us to basically tell d3 which data will be scaled here. And for that, we can use our dummy data and now call map on this, which is a built-in command available in JavaScript, which basically will transform this dummy data array to another array with different data in it. And essentially, I want to create an array which only holds my categories. So where I don't have objects with values and categories, but just an array full of text, full of strings, so full of China, USA, India, and Germany. And we achieve this by using map, and to map we pass a so-called anonymous function, an anonymous arrow function to be precise, where we get an argument which will be passed in automatically by JavaScript in the end, which uses map, and which then, and that's where you need to add an arrow, equal sign and greater sign, which then is passed into the function body of this inline anonymous function. So that's like a mini command we define on the fly here. And inside of this function body, so on the right side of this arrow here, we simply return or point at the data we want to pull out of our data. And in my case, that's the category. And this in the end just tells JavaScript that I want to map my array full of objects into an array full of categories, so full of these strings. And again, to make this easier to read, I'll split it across multiple lines here. Now that's still not all. That's a first step, but not all. I also want to call range round on that. I call the range round command on that. And range round now will make sure that we also tell d3 and the scale band command not just which data to scale, but also which available space we have for that. Here you need to pass in an array, so square brackets, and then you have a lower and an upper bound. And the lower bound here is 0 because the x-axis starts on the left with 0 and will always have that point. But how far we can go to the right, that's the question. And that simply is the available width we have here in our container. Now that available width of course changes when the user shrinks this, for example. So therefore here we want to get the available width, and we can get this out of our options here. I'm going to create a new constant width, and there I simply store data from my options, to be precise from the viewport there, which holds information about the available space, and there I got a width. And whilst we're here, we can already extract the height as well. And that's the currently available width and height, which should also update when our chart is resized. And it's this extracted width which I assign here as an upper bound. Now last but not least, I want to have some space between my bars, and that can be achieved by adding padding here. And I will simply set this to 0.1, which basically means 10% of the available width will be reserved for space around the bars. With that, we have our X scale. Now we can create our Y scale here. So for that, I create Y by calling scale linear. So this other command we imported. And scale linear also receives a domain so that it knows which data should be mapped along the Y-axis basically. And here we pass in an array, just as we passed in an array here, just a mapped array. But here we create a brand new array. And there, I basically want to say that I want to have a Y-axis that also starts at 0 and then maybe goes up all the way up to the tallest value we have here, 11. Or maybe the tallest value plus 2 or 3, so that there is always some empty space above the tallest bar. So we could just enter 13 here, or we use a little helper function, a helper command we get from d3, which we also can import here. And that's the max command, which allows us to calculate the maximum dynamically. And we simply call it here. And to max, we pass our dummy data. And then a second argument, which is basically now again such an anonymous inline function which runs on every data point and pulls out the value that should be compared across data points. So here this again gets every data point and should then return what we want to compare. In my case, that's the value. So this will now have a look at all values all together, pick the highest one. And then I'll simply add 2 so that there always is some empty space above that. Now, just as before, we also don't just need to refer to the data, but also keep the available space available in the viewport. And for that, I'm calling range. Range round simply makes sure that the generated positions in the end are rounded. And with range, we get the exact positions. For the x-axis, I'm fine with rounded values. For the y-axis, I want to have exact bars which have the absolutely correct height, and therefore I'm not going to round here and just call range. And to range, we now again pass our upper and lower bound, but here's one important thing to know. The x-axis goes from left to right. The y-axis actually goes from top to bottom. So the overall coordinate system we're working in starts in the top left corner. That's just how it is, and that's of course typically not how we humans think. Therefore, the lower bound here actually is our upper bound in our bottom left corner coordinate system we as humans use, because we start at the top in our code here, in our programming language, so to say. So therefore, the upper limit here is the height, and we go all the way down to 0, just because we start in the top left corner with that coordinate system. Well, and that was a lot of talking. But with that out of the way, we can do two things. First of all, I will reach out to my SVG, to my root element again, and there set attributes for width and height, which is basically the available width and height we got in the viewport, so that the overall SVG element, which holds the entire chart, is sized correctly. But now I, of course, also want to use my X and Y scales that were created, and we're going to use them down there. For the width, we, for example, can call x.bandwidth. That is a built-in command we can call on our X scale, which gives us an equal width for every bar in the end. So this takes into account the total amount of data points and gives us an equally sized width for all the data points, also taking into account that free space that we want to have between our bars. Now for the height, it's a bit more complex. Here, I actually want to use the position on the y-axis, but that starts at the top, so I actually need to deduct this from the available height. And I also need to be able to pass in my concrete data point value to y, so that y, which actually turns out to be a command too, is able to calculate the position for a given value of a given data point. Because of course not every data point should have the same position on the y-axis. It shouldn't have the same height. Now for that, d3 got us covered. Besides passing in a hard-coded value here, to height and weight and so on, we can also pass in such a inline anonymous function. And there we get access to our data point. And on the right side, we now need to return the value we want to use as a height. And here we can now call y as a function, so as a command with parentheses, and we pass in data point dot value. Now that, however, is not all we need. As I said, because we start at the top, we need to deduct this from our available height like this. And now we can also set the x and y axis position. For the x-axis, we simply, again, use this inline function approach and now call x as a command and pass in data point dot category, because it's the categories we use on our x scale. And then, last but not least, we add attribute y. And here, again, we use this inline function, and we call y on data point value. Now here we don't need to deduct this from anything, because here I'm really just interested in the position on the y-axis, and since I already calculate the height by deducting y from the height, I don't need to do it here. With that, if we now save all of that, and we go back here and reload, we should see 4 bars at this point. And again, if you're not seeing this, attached you find a code snapshot where you can compare my code to yours. Now these are 4 bars. Of course, with boring colors, no labels, and also just based on dummy data, not the actual data we could attach here. But it is an important first step, because this is how we will generally render our bar chart to the screen. Now, with that, of course, that's not where we want to stop. Instead, now we want to progress, and we want to make sure that instead of using this hard-coded dummy data here, we can actually get the data from Power BI and use that in our chart.